Alright, hi everybody. Today we're doing example 1 from section 7.4. This section is focuses on real numbers. Real numbers are rational numbers and irrational numbers together that form the set of real numbers. So let me explain to you what a rational number is. A rational number is a number that can be written as the ratio of two integers. So what that means is it can be written as a fraction with one integer divided by another integer, so a ratio of integers. An irrational number cannot be written as the ratio of two integers. So an irrational number couldn't be written as like 3 divided by 2. That would be an example of a rational number. The square root of any whole number that is not a perfect square is irrational. That's an example of an irrational number. So taking the square root of 2, that will give you an irrational answer. The cubed root of any integer that is not a perfect cube is also irrational. So if you take the cube root of 10, that's going to give you an irrational answer. Can't be written as a ratio of two numbers. The decimal form of an irrational number neither doesn't terminate or repeat. Okay, so that doesn't happen in irrational numbers. So for this problem here, for example 1, we're supposed to determine whether they're rational or irrational. So we look at it'd be helpful if you looked at your key ideas at the top of the page and the information before the key idea on the page before. Maybe if you had your book out while we're doing this, it'll be a lot easier for you to follow along with me. So the square root of 12 is 12 a perfect square? That's what we need to ask ourselves first. Is 12 a perfect square? It is not, which means that by definition from our examples of what is irrational, that means that this is an irrational number. This answer would be irrational because we're not taking the square root of a perfect square. If it was the square root of a perfect square, the answer would be rational. It could be written as a ratio of two numbers. The reasoning 12 is not a perfect square. Negative 0.25. Negative 0.25 repeating is it is rational because it can be written as a fraction, as a ratio. So it's rational. And like we discussed earlier, if it didn't repeat, then it would be irrational. Oops, I kind of skipped ahead. So negative the square root of 9, and we want the negative answer. So we taking the square root of 9, is 9 a perfect square? That's what we need to ask ourselves. And 9 is a perfect square, which means that our answer, even if it's just the negative root of 9, it would be rational because it would be an integer. And an integer, any number, can be written as a ratio of two numbers because think about it this way. If you have a whole number like 3, it can be written as 3 divided by 1. 3 divided by 1 is still 3. It's a ratio. D down here, 72 divided by 4. It is rational because it is equal to 18. 72 divided by 4 is equal to 18, which means that it can be written as a ratio of two numbers, 18 divided by 1. It's equal to 18. Remember what I just said about that example right beforehand. Any whole number, any integer can be written as a ratio of two numbers. It'd be 18 divided by 1. Is pi rational or irrational? So looking at pi, it is an irrational number, and that is because the decimal form of pi neither terminates nor repeats. It kind of goes on forever without a repeating order, so it's irrational. If you feel comfortable with these examples, try them on your own on the next page. Otherwise, I'd read the key ideas in the book because it gives you a clear description of what irrational and rational numbers are.